This is the activity on midpoint theorem. The objective of this activity is to verify that the straight line which joins the midpoints of any two sides of a triangle is parallel to the third side and is equal to half of it. Let's understand this concept first. So if you have a triangle, let's label the triangle as ABC, and then we mark the midpoint of AB as P and midpoint of AC as Q and join this line PQ. So this line PQ is the line which joins the midpoints of two sides AB and AC of triangle ABC. The midpoint theorem states that this line PQ will always be parallel to the third side, that is BC, and the length of PQ will always be equal to 1/2 of the length of BC. So if BC is 8 centimeter, PQ will automatically be 4 centimeter and PQ will be parallel to BC. We can prove this geometrically also, but in this activity, we are going to prove it using some material. And the material required for the activity are white drawing sheets, tracing paper, sketch pens, geometry box, scissors, and glue for pasting part. Let's see how we can verify midpoint theorem using this activity.
In this activity, we will be trying to prove the midpoint theorem. That is, if you take a cutout of a triangle, the measurements of the triangle doesn't matter. You can take any random triangle. You can see the triangle which I have taken is, suppose, A, B, C. And I have marked the midpoints of the three sides. P is the midpoint of AB, Q is the midpoint of BC, and R is the midpoint of AC. Now I have joined PR, I have joined QR. You can take one more cutout which is exactly same as the first one. You can see this is a colored sheet of paper which I have used, and this triangle and the original triangle are exactly same. That means they are congruent. And I have drawn all those lines which I have drawn here and then cut it into three different parts. Now I just require one part, that is this triangle, and the other two parts are discarded. After that, I will take this triangle which is now cut out and try to place it on this triangle above. You can see this is exactly the same. And surprisingly, if you place this on the triangle RQC, you will find that it overlaps RQC also. And that proves that triangle on the top, that is triangle APR, is actually congruent to triangle RQC. So if these two triangles are congruent, then their corresponding parts are equal, and therefore this angle 1 and this angle 2 are equal. And if angle 1 and angle 2 are equal, they form a pair of corresponding angles, and that proves that the line PR and the line BC are parallel, because only in case of parallel lines the corresponding angles can be equal. This is the first part where we have proven that the line joining the midpoints of two sides of a triangle is parallel to the third side. Now I want to prove that PR is half of BC. For that, you can again see that the side PR is equal to the side QC. That's also using CPCT, that is corresponding parts of congruent triangles. So PR equal to QC by CPCT. But you also know that QC and BQ are equal because Q is the midpoint of BC. Also, BQ equal to QC, and therefore all the three sides are equal. So if PR, BQ and QC all three are equal, that means PR is half of BC. So coupling the first result and the second result together, you have actually proved the midpoint theorem. That is, a line which joins the midpoint of two sides of a triangle is parallel to the third side and half of it. And that completes our activity on midpoint theorem.